Okay, so before I let you do the lab that comes with this unit, I want to do 3 things in a 10-minute video. First, I want to talk about good practices when working with your own data. When you work with other data, you might actually have to import other data formats, so I give you a few examples for this. Second version of the same name, this is very useful. So if we open this, all our formatting is already gone, and we can clean this up even more. So we don't want comments in here. We want simple names, so I'm just calling this treatment ID. This was height at age 5, and this was DBH at age 5. So now this is something, so we'll resave this here. Yes. This is something that we can import into R, that R will understand. And yet I also have all the other information available. So if I want to go back and see what the numbers really mean, I have this file, and for analysis I have the simplified file. So that's generally a good setup. Now let's bring this in and do some analysis. And the beauty of our setup is that we can just copy the script and the shortcut, put it here, and we double click Start R. We can open a script, and so it's the old script, but it's nice to start with something. So now we can simply adopt the script. We say on data, Control R, we run it, we have a look how it, if everything imported right. We can actually look at the whole data set here. It all looks good. We attach it, and for the box plot we have to change the syntax a little bit, and we go over these commands later in much detail. So for now I'm just typing this. So in this case, height 0.5, we want this as a function of treatment. So there you see that's our treatment effect, the thin treatment. The trees grow a lot bigger than in the control. And we could also run our statistical test, so we'll just copy that syntax here. It's just a little different because the data is arranged a little differently. And so we have a statistically significant difference between our control and our treatment. 3 and 5.3 meters. So you can see the power of the setup by virtue of recycling some of your code and copying the start command. You can, with very simple code, very quickly get your analysis done. So this is a pretty good practice for working with R, and I summarize it here for you. So what you want to do is you want to enter your data in Excel with all the auxiliary info. Then create a simplified CSV. So the rule of thumb here is that you only use short variable names to just keep your code simple. 8 characters is pretty much a maximum. Use letters and numbers only, and maybe an underscore. Your variable names have to start with letters. You can't have numbers first. And what I do for variable names, I always make them all caps, so that way I don't have to remember whether I capitalize this, whether I had all caps or all small caps. Basically, variable names in my code are always uppercase and the rest is lowercase. Also in your CSV, you're only allowed one header row and your data, and no additional blank rows or blank columns. That you can still have in your Excel sheet, just not in your simplified table for import. And the last thing, it's really a good idea to always have these folders with just 4 files in it: raw data, your simplified data, your shortcut, and your script. And for each job, you simply create a new folder and copy the elements into it that you need. So in this context, it's also quite okay to use attach. The attach command is actually something in the R community that's not recommended, and we'll later see why. But as you start with R, it's actually very useful. And in this type of setup, it works completely flawlessly. So we don't have to worry about those limitations. So the next thing on our to-do list is looking at other data formats. if we don't have CSV files, if we get data from other people, for example, and how to troubleshoot some of the problems that you may have. So I created a couple of, it's actually the same data set, but it's in different formats here. We have a plain text one here, our own data in plain text. So it's a tab delimited format that's very common. Especially if you're in Europe, you don't typically like CSV files because the comma that separates my columns is actually reserved for the decimal point. So that's a very common format. There's also something called a fixed width format that's very popular. It's very compact, so you don't actually have a delimiter. You just write everything in a column. And typically you have a header that says what this is all about and then where those variables reside. So my treatment is from column 1, 2, 3, 4, 5, 6, 7. My plot ID is 8, 9, 10. Then comes my height measurements, 3 characters, and my DBH 4 characters. So that's quite widely used. And we also have a dbf file here. That looks not so good, so we don't actually know what that is. So one way you can figure this out, we can just quickly Google this. So dbf format, looks like there it is. So that's a dbase format. Used to be a very nice database system. Nobody uses it today, but data may be in that format. So if we want to import this might be problematic. R will probably not have a routine, but there's probably somebody who's written a package to import it. And if you search something for R, Google is really not the best search engine for this. R is not a great search term, so there's something else. It's called rseek.org, and we can say read dbf files. I searched for this before, and there's a package foreign that we can install, and then we can read the dbf files as well. So if you don't know what to do, there's always rseek and Google to help you out. So it does have a read dbf function. That's great. All right, let's start R. And I actually already prepared a little bit of code so that you don't have to watch me typing how to import other data formats. So just like we had the .1 read CSV, we can import those delimited text files. So the only thing you do is you change the delim, you change the CSV to the delim, and it should work fine. We can attach it, and we can run our box plot and our t-test, and we get a bunch of error messages. Okay, so now we don't know what's going on. And I showed you already one way to figure out what might have gone wrong with your data import, and that's looking at the head of the data. And we can already see the source of the problem. So the person who had entered this, remember there was a comment here, he or she actually put that right into the data table, and R does not take that kindly. There's also another command that looks at the tail of the data set. So you can sometimes have a look whether you have the right number of observations, or whether there's some extra nonsense at the bottom of your data table. Another really useful command is also the structure command. So if we run this, it tells us what the structure of our data set is. So the first two variables are factor variables or class variables, and that's correct, treatment and ID. And then this one should be a numeric variable, but it's a factor variable, and it's because it has those characters in here. So that's already a red flag that something went wrong, and so then you can go back to your Excel spreadsheet and fix it. And you can also check the number of rows and the number of columns, see if that makes sense. These are other good check if you need to troubleshoot something. So let's have a look at the fixed width format. There's an import FWF, fixed width format, and what you have to specify is the width of your variables the number of rows to skip. Actually, I think we have to skip 7 rows here. And then you have to enter your column names manually. So let's do this and look at the head of that. And so that came in also fine. These are actually all just variations of the read table command. And if you want help, one thing you can do is whatever command interests you, you just add a question mark in front and then run this. And it will show you everything about this table command. So you can specify different separators, how many rows you skip at the beginning. There's also certain presets. So we use the read CSV, we use the read delim earlier. So the help file is typically quite good, and it has some examples at the end. Those tend to be quite useful as well. So let's do the last one, the read dbf. That was a bit of an odd format. R does not have a read dbf function. So we have to install this foreign package, and we can just do it from the menu here. Packages, install package. We pick a mirror, something near you. Then we have to look for foreign. There it is. And it's installing that package. And so if we run this now, it still can't find it. So you actually have to load that package into memory. So this is done with the library command. And you might get some warnings, but you can usually ignore those. And now let's see if it works. We can read the dbf file, and there's our data. So we're done. You can now have a look if you can do all this by yourself. There's a lab for those 3 last videos that you can work your way through by yourself on the computer. And if you want to look for other modules of this class, this is the address. So I'm always using this tinyurl.com shortener. And then you go to class 48 videos for other videos.